Hello, and welcome to another lesson on automated UI testing. In this video, we're going to take a big step together in writing your very first automated test case. By the end of this tutorial, you'll know how to create a simple yet effective test case using Selenium Python. Let's get started. First things first, what is a test case? In software testing, a test case is a set of conditions or actions used to verify a particular feature or function of your application. It's essentially a recipe for how to carry out a test, what results to expect, and how to evaluate those results. If you're working in software development, the chances are pretty good that you're using the Agile framework, or one of its variants, as a development process. Let's look at some Agile stories for automated testing. In the demonstration for this lesson, we're going to look at writing an automated test case for logging into a web-based to-do list application. Our first story will likely look something like this. As a user, I want to log in using my username and password so that I can access my account. We then have a series of tasks associated with our story. A single Agile story for test automation does not directly equate to a single test case. Instead, it represents a broader objective or level of functionality that needs to be achieved, which may encompass multiple test cases. Agile stories represent high-level functionality and user requirements, capturing what needs to be achieved and the value it brings. Test cases provide detailed, specific steps to validate individual aspects of the functionality described in the Agile story. In practice, each Agile story can result in multiple test cases to ensure comprehensive coverage of all acceptance criteria and possible scenarios. Let's look at our first test case. It deals with successfully logging into our application using valid credentials. To begin, the user should be on the login page. Our automated test should enter a valid username, then a valid password, and then click the login button. If we are successfully redirected to the home page, then our test passes. Let's take a look at our app for this next demonstration. The aim of automated testing is to reproduce the workload of manual testers, so we need to see how the application behaves manually. Let's try to log in. We get an error message. This is because we haven't registered. Let's click the registration button and fill out the form. We have successfully registered. Now let's log in using the credentials we just created. If we try to log in with just a username, we get an error message. If we try to log in with just a password, we get another error message. When we log in with both a username and a password, we are successfully redirected to the home page. And when we click the logout button, we return to the login page. Let's assume we're testing a clean instance of our app, so we have an empty database of registered users. In order to log in successfully, we need to register first, so we need to either alter our test case to accommodate this requirement or add a precondition that says the user database is loaded with at least one user profile we can use to log in with. We are going to add a test case involving registration. This is called a dependency because login depends on using registered credentials. Let's open our IDE and begin coding our first test case. I'm going to call my test case login and save the file. Let's import some packages: time, logging, unit test, and some Selenium packages. We want WebDriver by, weight, and expected conditions. By is the mechanism we use to locate elements within a document. WebDriver weight allows us to declare implicit and explicit weights. Expected conditions are classes used to describe what needs to be weighted for and are used with explicit weights. Next, we create a class named tags. We will place our XPaths in this class and reference them in our test script using the dot operator. We will place our test code inside another class. This class needs to share the name of the file, testcase_login, and it needs to inherit the test case class in unit test. Our first method needs to be the setup method. Set up the driver and the logger in here. The file name is a string identifying the path to and the name of the log file. The level of logging also needs to be set. For the purposes of this demonstration, I'm going to set it to debug. I'm going to name our second method test1. During execution, the order in which test case methods will be run is determined by sorting the method names with respect to the built-in ordering for strings. However, this pattern of execution can be disabled or just circumvented with clever naming. Test 1 will test registration and login. We'll use the assert in method to check for the title of the website as a confirmation that we're on the correct web page. Use the find element method from Selenium to find the register button by its XPath. Then click the register button using the click method. This is the pattern we're going to use throughout this demonstration. Find an element by its XPath and then either click it or enter text. To enter text into a text field, like the first name field on the registration page, use the send keys method. The find element method takes two arguments, a by strategy and a locator. The send keys method takes a string. The calls to sleep are not necessary. They will pause the execution of the script and slow down the demonstration enough so that we can see what's happening on the screen as the test runs. After we click the Register button, we want to check and make sure that we're redirected back to the login page and that we see the proper response message. So we create a Boolean called SuccessCheck. We call WebDriverWait and pass in our driver object and a time of 5 seconds. This means the test will wait a maximum of 5 seconds for an expected condition to occur before timing out and terminating the test. To wait for an expected condition, we use the dot operator and call the until method. We pass in a call to the visibility of element located method in the expected conditions class. This method takes two arguments, a buy strategy and a locator. In this example, the locator is the XPath to the message we get on the login screen after we successfully register. If success check is true, we proceed with logging in using the credentials we just registered. Again, we use the same pattern as before: find element, send keys, and click. We then do another check, this time to make sure we've properly logged in. Create another Boolean called login check. Like success check before, we want to wait until an expected condition occurs before moving on. In this example, we're waiting for the logout button to be clickable. This makes sense since we know the logout button is present on the home page. We will also want to test whether the logout button works in a future Agile story. So we wait for the logout button to become clickable using element to be clickable from expected conditions, and once it becomes clickable, we click it. We then make our third and final check, our logout check, by waiting for the login button to become clickable. If the logout button works correctly, then we should be redirected to the login screen. If the login button is visible and clickable after we log out, then we assert true. However, if our first success check fails, we raise an assertion error. Finally, we add a teardown method and close our driver. Don't forget to add a conditional statement for syntactic sugar. Now, we need to do some web scraping to complete our test code. Let's write an XPath to the username field on our login page. We can use the name attribute to write a valid XPath starting with the input tag. We can use the same XPath to point to the password text field just by replacing username with password as the name attribute's value. We define the XPath for the login button using the button tag. This tag contains text, which we can use in our definition. Let's try to log in using credentials we know won't work. As expected, we get an error message and we stay on the login page. Let's define an XPath for this error message next. We use the div tag and look for a class that contains an alert. Next, we'll try to log in using only a username. We get an error message complaining that we need to enter a password. Let's write an XPath that points to this element. Let's try to log in using only a password next. We see an error message complaining that we didn't enter a username. Let's write an XPath that points to this element. Let's write an XPath for the register link. Start with the button tag. The register link is on the same level of the DOM as the login button, so we can use the following sibling axis to point to the register link through the login button. Let's go into the register page now and web scrape XPaths to the name and password fields. All of these XPaths start with the input tag, and we can use the name attribute. The XPath for the register button starts with the button tag. Fill out the fields and click Register. We are redirected back to the login page and there is a message notifying us that our registration was successful. Write an XPath for this element. Starting with the div tag, we look for a class that contains a success alert. Log in using our new credentials. We are redirected to the home page after clicking Login. We now want to write an XPath that points to the Logout button. Start by using the button tag. Our automated test is now complete. Let's run it and see what happens. Success. Our first automated test has passed. Let's look at the logs. Our test log doesn't look very readable, does it? We'll work on making this more human readable in later demonstrations. Our second test case deals with logging in using invalid credentials. To begin, the user should be on the login page. Our automated test should enter an invalid username and password and then click the login button. If an error message is displayed, our test passes. The third test case involves more validation. To begin, the user should be on the login page. Our automated test should enter text into the password field and then click the login button. If an error message is displayed saying a username is required for login, our test passes. In our fourth test case, Our automated test needs to enter text into the username field and click the Login button. If an error message is displayed saying a password is required for login, our test passes. Define a new method named test2. This will test login without registration. Use find element with the by strategy in the XPath locator for the name field and password field to locate the text fields, and then use send keys to enter text we know is valid. Finally, click Login and check for the appearance of the error message using WebDriver wait with until and the visibility of element located method from Selenium's expected conditions class. The XPath locator should point to the error message. Define a method named test3. This method will test to make sure the no username error appears on the login page. Use send keys to enter text into the password field and then click Login. Check for the appearance of the error message using WebDriver wait with until and the visibility of element located method from Selenium's expected conditions class. The XPath locator should point to the no username error. Define a method named test4. This method will test to make sure the no password error appears on the login page. Use send keys to enter text into the username field and then click Login. Check for the appearance of the error message using WebDriver wait with until and the visibility of element located method from Selenium's expected conditions class. The XPath locator should point to the no password error. Let's run our test and see what happens. All four methods run successfully. Let's look at our last Agile story. As a user, I want to log out manually by clicking the Logout button so that I can securely end my session. The first two tasks were covered under our first test case. We click the Logout button from the home page and then check for the presence of the Login button after we're redirected back to the login page. However, we still need to validate that the Logout button is always accessible from any page within the user session. There is only one other page the user can go to, the Manage Users page. We can write an automated test to verify the Logout button is present on the Manage Users page and then log out from there. That will be our next task. But before we move on, I'd like to review what you've seen in the demonstrations so far and highlight important pieces of test code. Selenium WebDriver offers various methods to interact with web elements. These are essential for creating robust automated tests that can navigate through web pages and interact with different elements like inputs, buttons, and drop-downs. Find Element is one of the most fundamental methods in Selenium WebDriver. It allows you to locate a single element on the web page using different strategies like ID, name, XPath, CSS, and more. In our example, we used the by strategy for XPath, and our locator was an XPath string. The attributes available for the by class are used to locate elements on a page. These are the attributes available for the by class. Using the by strategy makes your code more readable and maintainable. It clearly specifies the type of locator strategy you are using to find the element. Once you've found an element, Selenium allows you to interact with it in various ways, such as clicking a button, entering text, or selecting from a drop-down. These interactions depend on finding the element first using a by strategy in a locator and then calling another method like click or send keys to do something functional with that element. In dynamic applications, elements may not be immediately available. That's where WebDriver wait combined with expected conditions comes into play, allowing your tests to wait for certain conditions to be met before proceeding. In our example, we combined the call to WebDriver wait with the call to the until method. The expected condition method, visibility of element located, also takes a by strategy and a locator. This technique is crucial for dealing with elements that load asynchronously, such as those loaded via AJAX requests. It helps prevent your tests from failing by trying to interact with elements that aren't yet ready. Expected conditions offer a variety of common conditions you can wait for. These include waiting for elements to be visible, elements to be clickable, or even checking if a text is present in an element. We used two expected conditions in our test case: visibility of element located, which is an expectation for checking that an element is present on the DOM of a page, and visible, an element to be clickable, which is an expectation for checking that an element is visible and enabled such that you can click it. These conditions are not only powerful but flexible, allowing you to write tests that are resilient against varying load times and dynamic content. Let's return to our last Agile story for this lesson. We still need to validate that the Logout button is always accessible from any page within the user session. This last test case will follow the same pattern we used in our login test case, and since there is only one other page on this app, we won't have to navigate too much. Let's start by making a new Python file called testCaseLogout. We can copy the import statements over from testCaseLogin. We can also copy over the tags class and the setup method. Remember to give our log file a new name. We can also copy most of test 1 up to the login check. After the login check, we want to check for the presence of the Manage Users link. Let's write an XPath that points to this element and add that XPath to a variable in our tags class. For our login check, let's look for the presence of our new XPath and click it if we find it. Once we click Manage Users, we are redirected to the users page. Write a new if statement using login check again. If the logout button is detected on the users page, we should click it, after which we should be redirected to the login page. Let's add another check using logout check. Remember, this is a Boolean that returns true if the login button is detected on the page. This should only occur on the login page. If the logout check is true, we assert true. Let's add the teardown method and our if conditional. Okay, we're ready to run our new test script. Whoops, looks like we've got a problem somewhere. Okay, I forgot an XPath that points to the success message after registration. Now let's rerun the script and see what happens. We have a passing test. Let's recap. Our login test case tests user registration, login, and logout from the home page, attempted login without registering, and it checks for the presence of error and success messages. Our logout test case tests registration, login, it checks for the presence of the logout button on the Manage Users page, which is the only other page besides the home page, and it tests the logout button's functionality from the user's page. Based upon our Agile stories and their related tasks, we have adequate test coverage. We can now move on. That concludes Lesson 3.2. Mastering the use of find element, WebDriver weight, and expected conditions will elevate your testing game and make your Selenium scripts much more reliable and effective. Experiment with these tools to see what powerful tests you can build. In our next lesson, we're going to write more test cases for the to-do list application, so stay tuned.